All right, guys. So I'm just going to give you some notes for how to complete the assignment 003, Trig 003. Okay, so first of all, just a couple, just kind of review what is trigonometry. So trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. So everything we do this with trig comes back to angles and side lengths of triangles. And we're going to focus only on right triangles. So everything we're going to see, that's what trigonometry is. So the next thing is some key terms. Types of angles. So you have acute angles, less than 90. Right angles, exactly 90. Obtuse, between 90 and 180. You have straight angles, or 180. Reflex angles are greater than 180. And a full rotation is exactly 360 degrees. Okay, so I'll post this video along with the notes that I'm reading right now, so you can kind of print them out on your own and put them in your notebook, or I highly suggest you take notes while you're watching the video so that you don't need to go back and watch the video. If you need to pause it, whatever you need to do. Okay, so two ways we measure an angle opening. So the first way, well, first of all, there's two directions. So you look at the left. So the left side, the arrow is going this way. That's a positive angle. That's why all of these angles here are positive. Okay? So counterclockwise is positive. And then the other way, the arrow, you see the arrow going this way. If I'm going clockwise, that's actually negative angle. So you can see all of these angles are negative. And then in radians too. Okay? So, that being said, there's two ways to measure angles. One is using degrees, and one is using radians. So if you're using degrees, and you're using a positive angle, it's going to start at 0 and then work its way up. So 30, 45, 60, 90, all the way around till you hit 360. But then you can keep going. If you keep going, it just builds on 360. So here would be 360 plus another 30. So it'd be 390, another 15, another 90. So you just keeps adding. So you can keep going and going and going and going, and it would just keep adding itself. Same thing with the negatives. With the negatives, you do the same thing. So you notice how it's negative 30 down here, and then it keeps going negative 90, negative 180, negative 270, and then it goes negative 360, and again, you keep adding them, so it just becomes a bigger negative, bigger negative, bigger negative. Okay? So, two ways we measure, degrees and radians. So in trig, we use radians. Okay? You're used to using degrees, but there's a way to convert, in which we've done a little bit of work with in some of the other work I've given you guys. So if you're converting, so if you want to convert to radians, what you're going to do is you're going to take the degrees, whatever degrees it was, and multiply times pi over 180. If you want to change to degrees, what you're going to do is you're going to take the radians and multiply times 180 over pi. Okay? So for example, 80 degrees. Well, since it's degrees, I'm going to use this one here. Oops, sorry, not that one. I want my answer to equal radians. So that's why I'm going to use this one here. Okay? So I'm going to go pi over 180 times, and then degrees. Okay? So now I have 80 degrees times pi over 180 degrees. Well, first of all, degrees is going to cancel out with degrees, so we have no more degrees. And then you're going to reduce 80 over 180. Okay, so divide them both by 10, and then divide them by 2. You're going to get 4/9 pi, which is the same thing as 4 pi over 9. Okay, so 80 degrees is the same as 4 pi over 9. Okay, 125. So 125, I'm going to use the same thing. So we have pi over 180 times 125 degrees. Okay, well, degrees are going to cancel out, no more degrees. And then you're going to have 125 over 180. Times pi. Reduce that fraction. So when we reduce 125 over 180, we get, grab my calculator here, we get 25, I'm dividing them both by 5, over 36 pi, which is the same thing as 25 pi over 36. Okay. So these mean the same thing. One's just in degrees, one is in radians. Okay, and then we can do the same thing, go in the opposite direction. Okay, so we need to figure out what degrees this is. So we have, what we're going to do is, we're going to multiply now, we're going to multiply times 180 over pi. And this will give us degrees. Okay, so the pi's cancel out. And then you try to reduce as much as you can. So this reduces to 2, this reduces to 90, and then I can reduce it again to 45. So now we have 45 times 19. 45 times 19 is 855. 855 degrees. So you're saying, how can we get 855 degrees if there's only 360? Well, it's because it's several revolutions, right? So if you go all the way around, that's 360. If I go again, that's another 360, which makes 720. And then this 720 leaves an extra 135. So 135 is going to be somewhere over here. Somewhere over here. That'll be one. That's what it'll look like. Okay. And then the next one. So 180 over pi times pi over 4. So the pi's cancel out. I get 180 over 4. So 180 divided by 4, I get 45 degrees. 45 degrees. Okay, so 45 degrees, that angle opening is going to start here, and it's going to go, this is 90, this is 0, this is 180, and this is 270. So 90, so 45 would be this angle here. Okay. Reference angles. Reference angles. So anywhere you have a reference angle measures the opening of the angle and the x-axis. So all reference angles will always be between 0 and 90 degrees, or between 0, pi, and pi over 2. Because 0 degrees is the same thing as 0 pi. 90 degrees is the same thing as pi over 2. Okay, so you look at this angle here. So let's start in quadrant 1. So quadrant 1 right here. So the actual angle measure is the green. The red down here is the reference angle. In this case, they're going to be the same. Whatever they are, they're going to be the same. But you look in quadrant 2, it's not the same. The green is the actual angle. The red is the reference angle. Okay, so the reference angle is going to be smaller than the actual angle. In quadrant 3, the reference angle is tiny. That's the reference angle there. But the actual angle, what's called the standard angle, is all the way around. So it's going to be bigger than 180, bigger than pi. Okay, and then same thing on the last one. The last one, the actual angle goes all the way around, almost 360. It's going to be more than 270, less than 360. But the reference angle is that little angle there. So it's always going back. Wherever the angle is, it's the reference angle is going back to the x-axis. Okay. So in this case, we'll do a couple examples. So we have one here, 132 degrees. Well, if this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270, so this is 0 pi, pi over 2, pi, 3 pi over 2. So 132 is more than 90, less than 180, closer to 90. So that angle, so what I would start is go till I get to there, right about there. I'm going to stop. So now what I'm going to do is I'm going to draw the angle. There's the angle in red. Okay, that's the actual angle. But they want to find the reference. So the reference is going to be from where the angle is back. That green part. That's the angle opening that I'm looking for. Well, to get from 132, because this is 132, to 180, you're really just subtracting those two guys. So when you subtract 180 minus 132, you're going to get 48. So this is 48 degrees. Okay. So the next one is 236. So 236, let me erase this. So 236, figure out where that is. Well, that's going to go around, around, around. It's going to be somewhere, let's see here, right about there. Let's say right about there. Okay, so let me draw the angle. Okay, that's the angle. So the black represents the actual angle. Now the reference angle is from that angle back to the x-axis. Okay. So to get to the black angle, or sorry, the path in black, what you're going to do is this is 180. To get from there to there is 180. And then we went a little bit more to get to 236. Well, the green, you can see that the green and the yellow just cancel each other out. So I just got to figure out what that yellow is. So if this is 180, if the orange is 180, how much more did I go? So that's just going to be 236 minus 180. So 236 minus 180, 56 degrees. Okay. All right. 5 pi over 3. 5 pi over 3. Well, 5 pi over 3. So when you're initially getting used to this, it's okay to change it to degrees if you're not used to working with them. So 5 pi over 3 so when you do that, you're going to get a 1, 6. It's 300 degrees. 300 degrees. So 300 degrees is right about there. Okay. So the black represents the actual angle. So let me draw the angle. Okay. The reference angle, so the black is the actual angle. That's the opening of the actual angle. The green here is the reference angle. That's not the opening, That's the reference angle opening. Okay, so if I'm at 300 here, to get to 360, that's going to be 60 degrees. So that's what the reference angle is. 60 degrees, since they gave it to us in terms of radians, we're going to have to change it. So 60 degrees is pi over 3. Okay. And the last one is negative 3/4. Negative 3/4. So that means I'm going to come this way when I start. So let's figure out what negative 3/4 pi is in degrees. Okay, so I'm reducing it. So negative 3 times 45 is negative 135. So negative 135. Okay, so I'm coming this way. So I'm coming this way. This is negative 90. This is negative 180. So I've gone too far. So I'm going to go right about here. Okay, so the angle opening, let me draw the angle opening. The angle opening is that's the angle opening. The angle opening is the black arc. Okay, the reference angle goes back to the x-axis. So that's going to be right here. How far away am I from 180? Well, if I'm at 135 here, negative 135, and I need to go to negative 180, that means I'm going to subtract the two. So 180 minus 135, and you're going to get 45 degrees, which is the same thing as pi over 4. Okay. All right, and that's all you will need for the assignment, which I will post on Google Classroom where you find this video.